This demonstration is for Robert at RCR Archery to show that merely raising and lowering the attachment point of a rear stabilizer does not affect the overall balance of the bow. So here is a simulated bow riser, and I've already installed two back bars, one attached very low, one attached very high. Both of these are going to position the rear weight at exactly the same place. The only difference is that one is going to be attached low and one is going to be attached high. So I need a front stabilizer in here, and we'll install the back weight in the conventional position. This would be roughly your bow grip, your pivot point, and front stabilizers below the hand, and the rear stabilizer is somewhere below the forearm. And what we can see is that I've already have this balanced out so that the riser hangs vertical. Now, if Robert's theory is correct, because of this low attachment, it's putting additional force on the bottom of the riser in that direction. So when I move this weight to the top attachment, that force should be reduced and it should rock forward. So we're going to put that to the test. So once again, the only thing that changed here was whether we were attached to the bottom of the riser or the top of the riser. And what we can see is that it doesn't make any difference. And the reason it doesn't make any difference is because the center of the mass of the riser and the center of the mass of the front stabilizer haven't changed relationship to each other. There's no leverage factor that you add this distance plus this distance to get more leverage. The only measurement that matters there is from the pivot point to the center of the mass of the weight. From the pivot point to the center of the mass of the weight. Doesn't really matter how you get there. You could come all the way off the top, come back around the back side and come to here. As long as this rod weighed the same as that rod, it would still balance the same because the center of all the masses would be the same. In case anybody's concerned that this weight is too high in relationship to what you'd see on a regular bow, I have a second position here which lowers the rear stabilizer in relationship to the grip and the front stabilizer. So once again, we're up here. This is roughly the pivot point, and the stabilizer is somewhere a little bit below your pinky, below your hand. And now that moves this back weight down in relationship to everything else. And once again, the riser is hanging pretty much vertical. That was kind of dumb luck, but it just happened to be that way. But when this settles out, if you can kind of reference off this bar back here, what I'm going to show is that once again, moving the weight to the lower position doesn't have any effect on the overall balance of the bow. And that is because, once again, whether in a top attachment or a low attachment, the weight is still in the same position relative to the weight of the riser, relative to the weight of the front stabilizer. So everything still balances out the same. Now, if you lower this weight, if you were to go from here to here, obviously that would make a change in the balance of the bow. But the attachment point itself doesn't make any difference, whether it's a high attachment or a low attachment. Now, if Robert's theory had any validity, that this additional weight is pushing harder on the bottom of the riser because it's a low attachment, this is 1 ounce. I would certainly think that Robert's theory, that would amount to more than 1 ounce on the back bar. So just for comparison, that's what one additional ounce on the back bar would do. And now you can see how far out of level that hangs. So that kind of gives an indication of how sensitive this system is. And if there was any significant change or any change whatsoever, it would have been reflected when I moved the back weight from the high mount to the low connection point.